All right. Okay, so you're with me. Okay, here we go. Now, take a look here. Whoops, forgot to turn this on. Hold on a second. I forgot something in today's lecture. This is Friday, February 23rd, and I forgot when my computer died, I got thrown off a little bit. I forgot one of the things. We're not doing the induction thing with the Henrys and stuff like that in section 2.8. It's not that big. I mean, it's a huge deal. It's a solenoid and how that works and stuff like that. But you got to move on. So, but one thing that I did forget was the back EMF. Okay, and here's from the slides. Now, we did do this part. Okay, and then we got to this part. I wrote this on the board, so you see the maximum voltage here and maximum voltage here. Because remember, the charge doesn't care if it's positive or negative. It just wants to get pushed. The charge down the wire is just going to get pushed. So there we go. And we don't worry about drift velocities or any of that kind of stuff. We just know that we turn on the lights, boom, it happens. All right. So, and here's what I was talking about. Now we haven't gotten to the huge electric generator from the power plant. This is when powering these houses, out at Riss Lake, it looks like. But anyway, not my neighborhood. Okay, but now, okay, inside that circuit, okay, that churning thing, that motor churning, guess what happens? Well, boom, boom, back and forth, back and forth, back and forth. That is going to create, gives rise to a counter torque that opposes the rotational motion. What's causing that counter torque? Well, it's the back EMF here that's working against the magnetic field, the change in the magnetic field. Okay? The current's coming, okay, so the current's coming out of the paper here. It's got a force going this way. It's pushing it that way. When it wants to, from the top view, it wants to be pushing this way. Don't worry about it too much. Just know that a counter torque happens in there. And you can see it here. Here's my AC motor. All right. Here I've got a motor that's turning. Here's my voltage. So I plugged it into the wall. Plugged the machine. A motor operating has two sources of EMF are present. Okay. The motor's turning. Now let's look at the circuitry. Let's look at what's going on inside the motor. All right. Well, this motor has a resistance. So you've got this EMF that's being generated inside here, caused by this change, the change in the magnetic field that's happening over here by the generator that's coming into the house. All right. I wish they'd have made this DC, and it's much easier to see. The Pearson book made it DC, and I'm going to do that on my notes. But anyway, so here we go. It actually works out. The homework type problem works out very simply. All right, but here we go. So we've got this thing operating. Here's the circuitry that's getting it to operate. All right, but inside it, it's creating its own back EMF. All right, that's opposing that motion. So notice what we have here. Going this way, and then this polarity is pushing this way. This one's pushing this way. So they're pushing against each other. This is not there when you first turn it on. So you get a lot of current, but the resistance is there. The resistance is there, so you get a lot of current and it comes out. So I'm going to go ahead and you get this thing called the back EMF. And the current then, when this thing is fully running, is the voltage being created that from the wall, say the wall cycle is 120, minus this back EMF, which is what they're talking about here, divided by R. That's your operating current. That's the operating current. There's also a starting current. All right, so let's look at a problem here. Okay, I'm going to go ahead and stop here. This is going to be a two-phase thing because I'm going to write down the problem here on the sheet and then go into it.